All right, greetings, scholars. We're continuing chapter 2 with section 2.2, linear equations in one variable. Okay. A few learning objectives. Solve equations in one variable. Solve a rational equation. Find a linear equation. Given the equations of two lines, determine whether their graphs are parallel or perpendicular, and then write the equation of a line parallel or perpendicular to a given line. So a linear equation in one variable can be written in the form ax plus b equal to 0, where a and b are real numbers and a is not 0. So given a linear equation in one variable, use algebra to solve it. The following steps are used to manipulate an equation and isolate the unknown variable, so that the last line reads x equals whatever your answer is, if x is the unknown. There is no set order, as the steps used depend on what's given. We can add, subtract, multiply, or divide an equation by a number or an expression as long as we do the same thing to both sides of the equal sign. Note that we cannot divide by 0. Apply the distributive property as needed. Isolate the variable on one side of the equation. When the variable is multiplied by a coefficient in the first stage, multiply both sides of the equation by the reciprocal of the coefficient. All right. Okay, so let's just see this in action. We're asked to solve this equation. We have 2x plus 7 equals 19. Okay. So we're going to constantly be using the inverse operation. Right? We're going to move items away from our variable so we can get the variable by itself or isolate the variable. So for instance, if I want to move that 7, the inverse operation of plus 7 is going to be minus 7. So we subtract 7 from both sides of the equal sign. Okay. And I'm just going to use this as a guideline. Again, whatever we do on the left side of the equal sign, we also do on the right side. Okay, so notice we subtracted 7 on the left and right side of the equal sign. A number plus its opposite, these add to 0. Okay, so on the left hand side, the only thing that's left is 2x. We bring down our equal sign. The 2x comes down. Let me see. 3 and 9 is what? 12? So then now we have 2x equals 12. Well, if we want to move the 2, and we're saying 2 times x, the inverse of multiplication is division. So we would divide both sides by 2. A number divided by itself is a 1. 1 times anything is itself. So then the x comes down. 12 divided by 2 is what? 6. Okay. Now, if we get this as an answer, whenever possible, you definitely want to check. So we ask ourselves, does this make sense in the context of the original? So let's just do a quick check. We're saying when x is 6, does the final result equal 19? 6 times 2 is 12. 12 and 7 is 19. So it checks out. All right. All right. So we're asked to solve here. Let's see. So with something like this, my recommendation is expand it all the way out, like do our distributive property whenever needed. And then we're going to use addition and subtraction. Any term that has an x, I'm going to get it to the left side of the equal sign. Any term that does not have x, I'm going to move it to the right. All right, let me get a copy of the original first. So we have this 4 times x minus 3 plus 12 equals 15 minus 5 times x plus 6. Okay? And again, we're going to be comparing, doing a left side versus our right side. Okay? So first, we're going to go ahead and distribute like this. And same thing here. We're distributing a negative 5 over here. Okay? So then on the left, we're going to get, what is that, a 4x minus 12 plus 12. On the right, it looks like we have 15. If we distribute a negative 5, that's going to be a negative 5x minus 30. Okay? So a number plus its opposite, these guys add to 0. So on the left-hand side, we're just left with 4x. On the right, we have, if we combine like terms, we have a negative 5x minus 15. And I'm going to move any term that has x, I'm going to move it to the left. So I'm going to use the inverse operation. The inverse of minus 5 is plus 5. So we're going to say, we're going to add 5x to both sides. Okay. A number plus its opposite, this adds to 0. 5 plus 4, that's going to be a 9x, equals negative 15. The inverse of multiplication is division, so we can divide both sides by 9. X equals a negative 5 over 3. And again, we should check by plugging into the original. I think I'm going to use my graphing calculator to check this one. So when we plug negative 5 over 3 on the left-hand side, and we plug it on the right-hand side, we should get the same answer, right? So what I'm going to do, I'm going to go to my y equals, clear, okay? I'm going to put the left-hand side in the first slot and the right-hand side in the second slot, right? Or if we said, another thing that we could do, if we said the left side minus the right side, and if it's going to be true, we should get 0. Like if the left is equal to the right and we subtract them, the result should be 0. So I think what I'm going to do instead is say the left side minus the right side, and then when I plug in this x, I should get a result of 0. All right? So we're going to say 4 parentheses x minus 3 plus 12. Now, I put the whole left side in parentheses, all right? That's not as crucial as this other one. I'm going to say minus, I want to put the whole right-hand side in parentheses. So I'm going to say 15 minus 5 parentheses, oh, that's not parentheses, parentheses, x plus 6. Okay? You got to make sure to close off your parentheses properly. So now we're saying that when x is a negative 5 by 3, it should make both sides equal. And so when we're subtracting, the result should be a 0. So let me call on that function I just typed in. I'm going to click on the button that says VARS. So on the right hand side of the calculator is a button that says clear. Left of that is a button that says VARS. I'm going to click on that. I think that's short for variables. I'm going to click to the right to go to Y variables. Number 1 for function. And number 1 again, basically what I'm doing is calling on the function I just typed in. So now I want to evaluate this function when x is a negative 5 by 3. Okay. And again, we should get a result of 0. So then that's about the best we could do. Okay. Solve this one. It's a couple of ways we can go about this. I'm a fan of trying to clear the fractions whenever possible. One technique that we have for clearing fractions of something of this nature is multiply the left side of the equal sign and the right side of the equal sign by the LCD, the least common denominator. All right. So the least common denominator, so the least common multiple between 2 and 3 is going to be 6. and it looks like we need at least one x. So it looks like our LCD, least common denominator, looks like it's going to be 6x. Okay. It wouldn't hurt to do like a Google or a YouTube search on how to find the least common denominator. Okay. So now we have this 2x under 7 minus this 3x under 5 equals 22 over 3. Okay. So again, we said we can multiply the left hand side and the right hand side by the LCD. So this times 6x and this times 6x. So now when we multiply the entire left, we need to distribute. Okay. So then what that's going to give us, we're going to have this 6x here. We're going to have one about here. That's going to be 6x times 7 over 2x minus 6x times 5 over 3x. Equals, I'm going to go ahead and simplify this guy. So 6 divided by 3 is a 2. 2 times 22 is 44. So that one becomes 44x. Okay. Now on this left hand side, the x's cancel, right? 6 divided by 2 is 3, right? So it's really a 3 up here, times 3. The x's cancel. 6 divided by 3 is a 2. So that's a 2, okay? I'll continue working over here. So now at this point, we have 21 minus 10 equals 44x. I'm just going to reverse the order. So now we have 44x equals, what is that, 11? So then x equals 1 by 4. Okay. Only way I know for you guys to like get comfortable with this is through exposure and repetition. I know that we're like asynchronous and remote. I think if somebody can somehow contact everyone and start a group meet, I think that's a great idea. There should be some instructions on how to connect with the free tutoring service. And Populi, like one of the first announcements that I post were instructions on how to connect with tutors. I think that's a great idea as well. Right, so you have to kind of be proactive, make a plan, take action, and execute. Right, that's kind of what it takes. Now, I'm going to check this in my graphing utility. So I'm going to go to my y equals. Let me see. Okay, so we can kind of put it in. I'm just going to put it in the left hand side. So then parentheses 7 divided by 2x minus 5 divided by 3x. Okay, so that's just the left hand side. So when I plug in this result, the answer should be 22 over 3 or 7 1/3, right? Okay, so I'm just going to call on that function I just typed in. I want to evaluate it when x is a 1 by 4. And I'm going to go to math. I want my final result to be expressed as a fraction. All right, so the answer should be 22 over 3. So we may have made a mistake somewhere. Did we forget to subtract? Let's go back and check our work, all right? Maybe we made a mistake somewhere. So 7 over 2x minus 5 over 3x equals 22 over 3. 6x looks like the proper LCD. That's a 3, which makes that, that's a 21. 10, right? 5 times 2, yeah. 10. 21 minus 10, I think is 11. 11 over 4x. Let me see, maybe I didn't type it in the calculator right. Let me go back to my y equals 24. 7 divided by 2x minus 5 divided by 3x Maybe that technique is off. Okay. Why is that not working? Let me think. Give me just a moment. 6 divided by 2 is 3. That's a 2. X is cancel. So then that's 44x. 21 minus 10 is 11. It's 1 by 4. Okay, well, something I'm doing is not right. Oh, maybe I need parentheses there. Let me, whoops. Let me retype this, but let me use some parentheses. Maybe that might be throwing it off. Maybe I didn't type it here properly. So then 7 divided by, I'm going to say parentheses, 2x. Okay, let's see if this makes a difference. We don't need this one here. Then we're going to say minus 5 divided by parentheses 3x. Maybe that's what it is. Okay, so let's try that again and see if it works. I think we can just take that exactly as it is. Okay, so that's what it was. The way we typed into our equation editor, yeah, that's the proper answer, right? So originally I had 7 divided by 2x with no parentheses, and I didn't realize that it was considering the x outside the denominator. So it was really doing 7/2 times x instead of, it wasn't forcing the x into the denominator. So here I realized that, well, maybe it's not forcing the x into the denominator. So I made sure I put parentheses around the denominator so we can make sure that it's recognizing that the x is in the denominator, right? Yeah, I don't know. That was weird. And so basically, you know, the calculator knows order of operation. But I guess the way I had it written without the parentheses, it's just going to do 7 divided by 2, get an answer, and then say that answer times x, which is not correct. We need to force that x to the denominator, so we had to introduce parentheses, right? So that's, I had typed it in here wrong, right? So our work is proper. We got to the bottom of it. I think that was a good learning moment, right? Good learning moment. So 1 by 4 should be good. Okay. So a rational equation contains at least one rational expression where the variable appears in at least one of the denominators. A rational equation is like fractions, right? It's like an equation that has fractions where the variable appears in the denominator somewhere. So given a rational equation, in order to solve it, factor all denominators in the equation, find and execute values that set each denominator equal to 0, find the least common denominator, multiply the whole equation by the least common denominator. If the LCD is correct, then there will be no denominators left. Solve the remaining equation and make sure to check the solutions back in the original equation to avoid a solution producing 0 in the denominator. So we'll talk about it. We'll see all this in action momentarily. So here we're asked to solve this rational equation. Okay. Ugh. Yeah, I don't know. Let me see. Okay, so we have this 2 over x minus 3 over 2 equals 7 over 2x. So it looks like in this case, the least common denominator is just going to be 2x. So again, our LCD is 2x in this case. So we're going to say this times 2x. And we're going to distribute a 2x over here. So ultimately it's going to become like this. 2x times this, 2x times this. All right? Okay. So these guys are going to cancel. The x's here cancel. 2 times 2 is a 4. The 2's here cancel. And we're left with a negative 3x. and that equals 7. Notice the fractions are gone, right? So we can add 3x and subtract 7. 4 minus 7 is a negative 3. So then x equals negative 1. Okay. And then we do need to check in the original. Okay. So now the original 2 over x minus 3 over 2. 3 over 2. Okay. If that equals 7 over 2x and we subtract it, then the final result should be 0. So I'm going to say minus 7 divided by 2x. Okay. So when we plug in this value of x, we should get 0. Okay. We should get 0. All right. So that's about the best we can do here. You know, if you plugged in when x is negative 1, negative 4 minus 3 is negative 2. Yeah, right? Okay. Solve the following. It says solve by factoring the denominator. Okay, so we want the least common multiple between 10 and 4. Okay. So another technique when you're just focused on like the coefficients for finding the least common multiple, you can start with the larger number being 10, right? So then you ask yourself, is 10 a multiple of 4? No. So then you say times 2. So then we say, okay, is 20 a multiple of 4? Yes. Is 20 a multiple of 10? Yes. So the least common multiple between 10 and 4 is going to be 20. So that means our LCD is going to be what? 20x. Okay. So if we have, on the left-hand side, we have 1 over x. On the right-hand side, we have 1 over 10 minus 3 over 4x. And if we multiply the left and the right side by the LCD, and again, on the right-hand side, we're going to have to distribute. So here we have times 20x. Here we're going to have times another 20x. And here we're going to have times another 20x. Okay. On the left-hand side, the x's cancel. So that's a 20. Over here, 20 divided by 10, so this becomes a 2. The x's cancel here. 20 divided by 4 is a 5. Okay, let's account for those changes. So the first term, it looks like we have a 2x remaining. And in the second one, it's going to be what, minus 15? Add 15 to both sides. 17.5. So x equals 35 over 2. Okay, and if I use my graphing utility to check, so we got 1 over x. If I say the left side minus the right, we got to distribute. Well, we could say minus the entire right-hand side. So we got to use our parentheses. 1 over 10 minus 3 over 4x. Close off that denominator and close off the right-hand side. So now if we let this be our value of x, then the result should be 0. 35 over 2. Okay. So that's about the best that we can do there. And you see the 35 over 2. Solve the following rational equations and state the excluded values. Okay. So the LCD for part A, we need one of each factor, right? So we're going to need an x minus 6 and we're going to need an x. So I'll just kind of write the notes here. We can like cross multiply whenever you have a fraction equal to another fraction. So we can say this denominator times that, this denominator times that, all right? So when you have a fraction equal to another fraction, another technique, a simple technique is to just cross multiply. Now if we cross multiply, we'll get 3x, and then the other one's going to become 5x minus 30. Okay. I'm going to subtract 3x and add 30. That's going to give me 2x equals 30. So then x equals 15. I feel like we're missing something. So excluded values. Okay, so because the original, like one of them is 5 divided by x, and we can't divide by 0. Well, this is the solution. I'm just going to go with this. Like I was going to have a little bit of an explanation, but this is the only thing that should make it true. I'll check it momentarily. Okay, so with part B, we don't have a fraction equal to another fraction, but we can use the technique. So we can't cross multiply here, not the way it's written, but we can multiply the left and the right by the LCD. The LCD in this case is going to be 2 times x minus 3, right? So that's not obvious. Yeah, I would do a search on how to find the LCD, or try connecting with your classmates, or do a live session with me, or connect with the tutors, right? That takes practice and exposure and just a little bit of digging, okay? So, for instance, I'm also kind of like a little bit short on space. So I'm going to say this guy times 2x minus 3, so, sorry, times x minus 3 times 2. Same thing over here, x minus 3, and same thing here. All right, we're basically multiplying each term times 2 times x minus 3, right? So when we do this, on the left-hand side, this is going to cancel this. And it's just going to leave us with just 2x. Okay? Now with that middle term, the x minus 3's cancel. So this cancels this. 5 times 2 is 10. With that last term, this 2 cancels this 2. We're left with a negative x minus 3. So minus x minus 3. Okay? So then we get 2x equals 10 minus x plus 3. Okay. And then we can add x on both sides. We'll get 3x equals 13. So then x equals 13 over 3. I feel like I'm missing something. And then for part C, the LCD is 2 times x minus 2. So we're going to multiply this times 2 times x minus 2, this one by 2 times x minus 2, and this one times 2 times x minus 2. And I'll check these in just a moment before I look at the answer. So then when we do this, this cancels this. That leaves us with a 2x there, equals, this cancels this. That leaves us with a 10. Is this the same thing? No. 10 minus, this 2 cancels this 2. So that's minus an x minus 2. Okay. 2x, 10 minus x plus 2. 3x equals 12. Divide both sides by 3. X equals 4. Okay. Excluded values. I mean, for the excluded values, I guess those would be from the original. Like in part A, we can't divide by 0, so x can't be 0 or 6. In part B, x can't be 3, and in part C, x can't be 2. You know, but we got these as solutions. I'm just going to use my prepared notes just in the interest of time. 15, 13 over 3, and 4. 15, 13 over 3, and 4. All right. Yeah, and what we said for the excluded values is correct. The excluded value is 6 and 0, right? Because again, the excluded values come from the original equation where we cannot divide by 0. So any x that makes the denominator 0, we have to exclude those values. Solve the rational equation after factoring the denominators. Okay. So now the first two denominators, I think they're already in factored form. So we have this x plus 1 under 2 minus x minus 1 under 1. But on the right hand side, we have x squared minus 1. That's a special factoring scenario. That's difference of squares. So that factors into x plus 1 times x minus 1. Okay. So then if we're going to distribute our least common denominator, and again, that just takes practice and exposure and a little bit of grit to understand least common denominators. You just got to keep trying, and eventually it sinks in. So the LCD in this case, you need one of each factor. Again, factors are things that we multiply and divide. Terms are things that we add and subtract. So we need an x plus 1 and we need an x minus 1. All right. So the least common denominator is going to be this times this. Okay. So we're going to say, let me just copy and paste. And I'm going to just shrink it down to size. Oh, that's fine. All right. So that times the LCD. This times the LCD. And this times the LCD. Okay. Oh, I don't even know what caused that. That was trippy. Yeah, that was weird. I don't know what that was. Okay. So we get some cancellations going on here. This x plus 1 cancels this x plus 1. That leaves us with, I guess we can expand it. It's going to become 2x minus 2. This x minus 1 cancels this x minus 1. So that's going to become minus x minus 1 equals, and then this denominator cancels this, and it just leaves us with a 2x over here. Notice the fractions are gone. Any term that has x, we're going to get it on the left. And any term that does not, we're going to get it to the right. So if we subtract 2x, so we're going to have 2x minus x equals On the right hand side, we're going to have 3. Ultimately, we're going to get x equals -3. The excluded values are going to be plus or minus 1 because they force it to be 0 in the denominator. Copy, okay. Again, I should use my graphing utility to check. I'm just going to use my prepared notes. All right, and you see it here. So they got the same result. And again, this is just a typed version of what we did. They might take a few different steps, right? So I usually try to do it fresh without looking at it in advance, and just do it based on based on my experience, and then compare it to the way the textbook likes to do it. And then notice we got the same thing, same solution with the same excluded values. So the slope of a line M represents the change in y over the change in x. So given 2 points, x1, y1 and x2, y2, the following formula determines the slope of a line containing these 2 points. Slope is going to be the change in y over change in x, which is y sub 2 over y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's also rise over run. All right. So find the slope of a line that passes through these points, okay? So we're given an ordered pair. I just like to label them x1, y1, x2, y2. And we just said the slope of a line, y2 minus y1 over x2 minus x1. Okay. So then if we plug in the corresponding components, our y2 is 3. Our y1 is -1. Notice my use of parentheses. x2 is -5. And x1 is 2. Okay. So on top, double negative. So that becomes 3 plus 1 is a 4. -5 minus 2 is -7. So then we just get a -4/7. Okay. So we're asked to identify the slope and the y-intercept of this. Okay, so this is given to us in slope-intercept form. Slope-intercept form is going to be our y equals mx plus b, right? So when it's in this form, it automatically gives us the slope and the y-intercept. So our slope is going to be a -3/4. And our y-intercept being b is going to be -4. Okay. So the point slope formula, this is a formula that we use when we're given a point and a slope and we're trying to find the equation of a line. Trying to find the equation of a line given a point and a slope. So y minus y1 equals m times x minus x1. If you're taking notes, it's a good idea to maybe have, like in your notebook, wherever you're organizing these notes, to have a formula sheet. So like every time you come across a formula, you can update your formula sheet with those formulas. And so that way, you know, when you go to use your notes, you know, you're like, oh, I got all my formulas right here, right? And the learning actually comes from building this yourself or creating it yourself. If you use somebody else's notes or you just use it in a book or whatever, it don't really sink in. But if you like take the time to like be neat and organized, create your own notes, create your own formula sheet, then it helps it to sink in a lot better, right? Either you'll just know it, you'll commit it to memory after doing that process, or you'll be like, oh, I got that right here. You'll just know it, like, because you've experienced it before. versus if you're just flipping from the back or flipping from the book or, just using reference, then you may or may not be aware of these formulas' existence, right? So write an equation of a line with this slope passing through this point and write the final equation of slope-intercept form. Now, I personally don't use point slope. I like to use the slope-intercept form, but for this one, just to showcase the point slope form, I'll go ahead and start with point slope and finish with slope-intercept. So point slope is going to be y minus y1 equals m times x minus x1. Okay. So they gave us this point. So this is our x1, y1, and we have our slope over here. Okay. So then if we plug those components in, our y1 is 8, our slope is -3, and our x1 is 4. Okay. So then if I solve for y is going to be equal to we're going to have a -3x plus 12 plus 8. So then y is going to be a -3x plus 20. Notice it has a slope of -3. And then to verify that it passes through the point 4,8, it's basically saying that when x is 4, the corresponding y should be 8. -3 times 4 is -12, plus 20 gives us a +8. So I think we got that result. Find the equation of a line passing through these pair of points. Okay. So again, I'm a fan of whenever I get ordered pairs like this, I like to label them x1, y1, x2, y2. So if we want the equation of a line, let's go ahead and find the slope. Again, my mentors will say every time you use a formula, just write it down. That constant repetition ingrains it into your memory. So the slope formula, so y2 minus y1 over x2 minus x1. Okay. So then that's going to be y2 minus y1 over x2 minus x1. Let me see. My y2 is -3. My y1 is 4. My x2 is 0. And my x1 is 3. So on top, it looks like we have a -7. On bottom, it looks like we have a -3. So the final result for the slope is a +7/3. Okay. So we have the slope. It looks like they gave us the y-intercept as well. Well, because when x is 0, y is a -3. So it looks like our y-intercept is -3. So then if we can just jump straight to slope-intercept, which is y equals mx plus b. Okay. So that's going to be y equals our slope is this 7/3 x, and our y-intercept is -3. So we got lucky, they just gave us our y-intercept off the rip. Okay. Okay. So let me showcase this in the graphing utility. If I go to my y equals, now our claim is that the solution is parentheses, or I guess we don't need it, 7/3x minus 3. So remember, it's going to do that fraction first, and then take that answer times x, which is what we want. And then we're going to say minus 3. So now what I'm going to go to stat. So in the upper left hand corner, there's a yellow or orange button that says second, and then to the right it says mode, and then delete. Just below delete, it says stat. I'm going to click on stat, and I'm going to go to edit. So we have two ordered pairs, our x versus our y. So let me see. We got 3 and 0 for our x's. The corresponding y is what? 4 and -3. Okay. I'm going to go back to stat. Let me see. So stat plot is the top left corner where we have the y equals. I'm going to hit second y equals to open up the stat plot. And I'm going to turn that on. Okay. So now when I go to the graph, we can see our 2 points plotted and the line passes through those 2 points. Right. So then that's about the best we can do. We show that we're clearly showing that the line passes through those 2 points. Okay, so that's correct. So the standard form of a line, another way we can represent the equation of a line is in standard form, where we have ax plus by equals c, where a, b, and c are integers. The x and y terms are on one side of the equal sign, and the constant term is on the other side. So find the equation of a line with a slope of -6 passing through this point, and write the equation in standard form. So I think we did one like this earlier where we used the point slope formula. I'm going to showcase how to use the y equals mx plus b, the slope intercept form, right? So we have the slope. Only thing we don't know is our y intercept, which is our b, right? So if we start with y equals mx plus b, okay. Let me see. Okay, so let me start with the slope. Our slope is -6. Our x is a 1/4. We don't know the y-intercept just yet, and our y value is -2. So we have one equation, one unknown, so we can actually solve for b, right? 6 divided by 4 is the same as 3/2. So then b is going to be equal to -2 plus 3/2. Okay, so that's going to be equal to a -4/2 plus 3/2 to give us a -1/2. So that's our y-intercept. So then, okay, I need to move this to the left. Okay. So our claim is that y equals -6x minus a half. Okay. So then to write this in the standard form, I'm going to multiply everything by 2 because of that denominator. So I'm going to say this times 2, this times 2, and this times 2. Okay. So then we'll get a 2y equals -12x minus 1. I'm going to add that 12x to both sides. So we get 12x plus 2y equals, looks like it's a -1. So notice if we were to solve for y, we would get a slope of -6. And then when x is a 1/4 and y is -2, so that's a 3 minus 4 is indeed -1. Okay. So 12x plus 2y equals -1. Find the equation of the line passing through these points. Okay, so let's start by finding the slope again. We have a set of ordered pairs. x1, y1, x2, y2, okay? We're going to find the slope between these. So that's going to be y2 minus y1 over x2 minus x1, okay? Our y2 is 4, minus our y1 is a negative 3 over x2 is 1 minus x1 is 1. Uh-oh. So if we were to plot these points will be stacked on top of each other, right? Notice that it's forcing us to divide by 0. So you can do something like x equals 1. It's really not a line, but it's a vertical line through x equals 1. Or you could say undefined, right? Let's see what the book says. So it's a vertical line x equals 1. Okay. Graph the equations of the given lines and state whether they are parallel, perpendicular, or neither. So parallel, perpendicular, neither is really a discussion on slope. Lines that are parallel have the same slope. Lines that are perpendicular their slopes are negative reciprocals of each other, right? Or in other words, lines that are perpendicular, the product of their slope equals negative 1. Okay, so what it asks us to graph. Let me start by finding the slope, right? So line 1, we have this 3y equals a negative 4x plus 3. Okay, if we solve for y, negative 4 by 3x, we divided both sides by 3, so that's going to be a plus 1. Okay, and if we consider line 2, we have this 3x minus 4y equals 8. So I'm going to add the 4y and subtract 8. We'll get 4y equals 3x minus 8. Divide both sides by 4. Y equals 3 by 4x minus 2. So the slope of line 1 is going to be a negative 4 by 3. The slope of line 2 is going to be a positive 3 by 4. It looks like they are negative reciprocals of each other. Notice that if we said the slope of line 1 times the slope of line 2, that's going to be a negative 4 by 3 times 3 by 4. Notice that this equals negative 1. That means that these lines are perpendicular. So we could say like line 1 is perpendicular to line 2. Okay, I'm just not going to graph it just because I'm being lazy. But the main thing is that we're saying that they're perpendicular. Right? A simple way to graph it, we can use our intercepts. You know, we already got it in y equals mx plus b. Notice that line 1 has a negative slope, line 2 has a positive slope. So they're going to cross at a 90-degree angle. So the slopes are negative reciprocals of each other, therefore the lines are perpendicular. Okay, we're almost there. 6 more slides. Okay. Write the equation of a line parallel to this passing through this point. So if we want our line to be parallel, that means our line needs to have the same slope as this guy. Then we'll have a slope and a point, and then we can kind of flow between those 3 equations of a line to find the equation of our line. All right? So we're given this 5x plus 3y equal to 1. Let's go ahead and solve for y. We got a negative 5x plus 1. Divide both sides by 3. Negative 5/3 x plus a third. Okay. So if we want to be parallel, that means our slope is going to be a negative 5 by 3. Okay. Now we wanted to pass through the point 3, 5. Again, I'm just a fan of using the slope-intercept formula. That's going to be your y equals mx plus b. Okay. Let me see. Our slope is a negative 5 by 3. our x is 3. We're solving for b, and our y is 5. Again, the 3 and the 5 came from passing through from the given point of 3, 5. Okay. So then we'll get that b equals, notice that these 3's cancel. So we add 5 to both sides and we get 10. It looks like our y-intercept is 10. So then the equation of the line should be negative 5 by 3x plus 10. Okay, negative 5 by 3x plus 10. Notice that when x is 3, the corresponding y is 5. Right? And you see it here. Then we got maybe one more example. Find the equation of a line perpendicular to this passing through this point. Okay, so if our line is going to be perpendicular, it needs to be the negative reciprocal of their slope. Our slope needs to be the negative reciprocal of their slope, right? So we need to find their slope first. So we have this 5x minus 3y plus 4 equals 0. I'm going to solve for y. So we'll get 3y equals 5x plus 4. Divide both sides by 3. 5/3 x plus 4/3. Okay. So that means our slope is going to be the negative reciprocal. So it's going to be a negative 3 by 5. Okay. Again, I'm just a fan of using the slope-intercept. Y equals mx plus b. So our slope is going to be a negative 3 by 5. Our x is negative 4. We're solving for b, and our corresponding y is 1. So then b is going to be equal to, so that double negative is positive, so we're going to have 1 minus 12 over 5. Okay. That's going to be 5 over 5 minus 12 over 5, negative 7 over 5. Okay. So then the equation of the line should be y equals negative 3 by 5 x minus 7 by 5. Okay. Okay, I'm just going to go with it, and I think that's good. Okay. So between the previous section and this section, that serves as like the content that we need for the week. We're gonna go ahead and end the session here, and from one beautiful mind to another. Until we meet next time, take care. Peace.